Okay, so a major application of calculus is optimization. So taking a function and trying to find where its maximum is. So, I'm trying to maximize profit as a company, or maybe you want to maximize efficiency as an engineer. In any case, this is where it starts with some basic problems. So here we have two positive numbers. So straight away, I'm going to start introducing variables. So I'll say two positive numbers. We'll call them x and y. These are familiar variables. So we know right away that x plus y is 16. Now, what am I trying to minimize? Well, smallest, right? I'm trying to minimize the sum of squares. So that would be x squared plus y squared. So I want to think of this as a function, and then I want to find the minimum. Find out where this function is minimized. Now I have a problem. In Cal 1, in Cal 2, these are single variable courses, so single variable calculus. If you want to do multivariable calculus, then you'll have to do calculus 3. But we're not doing that today, so we have too many variables here. So I need to eliminate one of them. So how I'm going to do that is I'm going to use my information to eliminate a variable. So I can solve for y here. Y is going to be 16 minus x. And then I have f will be in terms of just x. Like so. So I took my 16 minus x, plugged it in for y, thus eliminating a variable, and now I am in a calculus 1 situation. I have a function, I want to find its minimum. How do I do that? I take a derivative, set it equal to 0. I could expand this, but I would rather just jump into the calculus. Expanding is not generally helpful. Chain rule gives me times minus 1. So f prime is going to be 0, right? So that I can find maxes and mins. Let's clean this up. I get minus 32 plus 2x. 32 is 4x, giving me x is 8. So I have an x value. I have a critical number. Is that corresponding to a max or a min? Well, I have to check. So I take 8, put it on a number line. Let's say f prime here. And let's think about f prime of x, which is right here. It's 4x minus 32. So I'll do some test values here. Obvious thing to do is plug in 0 here, and I get a negative number. If I plug in, say, 10, I get a positive number, telling me that my function is going like this, down and then up. So this is indeed a minimum at 8. So therefore, f is, well, at its min at x equal to 8. And the question's asking me to find the smallest sum of squares. So I have to actually plug the 8 in here. F of 8 is 8 squared plus 16 minus 8 squared, which is 64 plus 64, 128. There's my minimum.